We already know the process to find out if the system is time invariant or time variant by checking the three compulsory and sufficient conditions. So a system is said to be time invariant if it satisfies or follows all the three conditions. Now in this presentation we are going to discuss what are split systems, and once we have the understanding of split systems we will find out if they are time invariant or time variant. So let's start with the first problem in this lecture, and the first problem is actually the 14th problem till now. We have completed 1 to 13th problem in the last two lectures, and in this lecture we will discuss 14th and 15th problem, and the two problems are based on split systems. So let's see what is the relationship between input and output. Output yt is equal to xt minus 1 when time t is less than 0 or negative, and it is equal to xt plus 1 when time t is greater than or equal to 0. So when time t is 0 or it is positive, yt is equal to xt plus 1, and when t is negative, yt is equal to xt minus 1. So you can see there is condition on time. There is condition on time, and whenever there is condition on time, the system is known as split system. So this particular relationship is the relationship of split system, and we are interested in finding out if this split system is time invariant or time variant. And for this again we will check if the three conditions are true or not. We will start with the first condition. In the first condition, we try to find out if there is any time scaling on the input side and also on the output side. On output side, we only have t here, so there is no time scaling. And on the input side, you can see we have t minus 1 and t plus 1. There is time shifting, no time scaling. So condition number 1 is true for this system relationship. Now we will check for condition number 2. The coefficients should be constant. There are two coefficients, one here and one here. So the coefficients are constant, they are not function of time. So condition number 2 is also satisfied. Now we will move to condition number 3. Any added or subtracted term in the system relationship except input and output must be constant or 0. Here there is no added or subtracted terms, therefore condition number 3 is also satisfied. And as all the three conditions are satisfied, the system is time invariant system. You will say the system is time invariant system, but this answer is incorrect. The system is not time invariant, but it is time variant, and I will explain why it is time variant by writing down the system relationship in some other form. Yt is equal to at x t minus 1 plus bt x t plus 1, and here at and bt are defined like this. At is equal to 1 when t is less than 0, and it is equal to 0 when t is greater than or equal to 0. Bt on the other hand is equal to 0 when t is less than 0, and it is equal to 1 when t is greater than or equal to 0. And if you try to compare the two system relationships, you will find they are same. In this case, when t is less than 0, yt is equal to xt minus 1, and in this relationship, when t is less than 0, at is 1 but bt is 0. So this part will become 0, and we only have yt equal to xt minus 1, as at is 1 and bt is 0. And when t is greater than or equal to 0, here yt is equal to xt plus 1. In this case, at will be 0, bt will be 1. At will be 0, bt will be 1, so yt will be xt plus 1. So the two relationships are same, and instead of writing it like this, we can write it like this, and you can clearly see we have two coefficients, at and bt, they are the two coefficients, and according to condition number 2, the coefficients should be constant, but here at is not a constant coefficient and also bt is not a constant coefficient. They are time dependent. They depend on time. You can see the definitions. They depend on time. So we can say that condition number 2 is violated for this particular system relationship, and therefore the system is time variant. The actual or the correct answer is time variant. So whenever you have any split system relationship given, directly write down the answer as time variant system, because in these systems there is condition on time, and whenever there is condition on time, you can represent the system like this. You will have coefficients which are time dependent. So I hope you now understand what are split systems and how to find out if they are time variant or time invariant. Now we will move to the 15th problem. The 15th problem. In this problem, output yt is equal to xt minus 2 when t is less than minus 3, and yt is equal to xt when t is greater than or equal to minus 3 but less than or equal to 2, and yt is equal to xt plus 2 when t is greater than 2. So this is how the system relationship is given, and you can clearly see there is condition on time, therefore it is a split system, and split systems are always time varying systems. If you want, you can represent this system relationship in this form, and you will find there are 3 coefficients which are time dependent, and thus the condition number 2 is violated and the system is time variant system. So this is all for this lecture. From the next lecture we will start linear and non-linear systems.